So welcome back students again. Before this, in previous sessions, we have studied about the theory of tangents to a curve related to application of derivatives. Let's discuss the meaning of normal and how to find its equation. Before this, we have studied that if x1 comma y1 is a point on a curve, so a tangent can be drawn at this point. Let this x1 comma y1 be the point of contact, not this, okay, through which the tangent is passing. This point is point of contact, okay. This is curve, this is equation. If this is tangent, this is curve, and we have studied that slope of tangent is obtained by dy by dx at point of contact, which is x1 comma y1. Point of contact means where the tangent to the curve x1 to the curve, if we assume that the equation of curve is y equals to fx, is touching the curve, and then to the curve y equals to fx is touching the curve at x1 comma y1. So x1 comma y1 is the point of contact, and to find its equation, this equation of tangent, the formula is very simple. The slope point form of a line when slope is given as m, which is dy by dx at x1 comma y1 into the equation of tangent. Now, what is the meaning of normal and how to find equation? Normal means the line which is perpendicular to the tangent at its point of contact. This line is called normal. Tangent is denoted by t and normal by n. As normal is perpendicular to tangent, as normal is perpendicular to tangent means what? Slope of normal into slope of tangent. We know that whenever two lines are perpendicular to each other, the product of their slope is -1. That is slope of normal, which is unknown, into slope of tangent. We already have calculated, it is dy by dx at x1 comma y1, which is the point of contact of tangent, equals to -1. So the slope of normal is -1 upon dy by dx at x1 comma y1, where x1 comma y1 is the point of contact of the tangent to which we have to find the normal, and x1 comma y1, which is the point of contact, is lying on the normal also. So we can now easily find the equation of normal, as we have its slope and we have a point lying on it. Using slope point form, y minus y1 equals to m into x minus x1, that is y minus y1 equals to -1 upon the slope is dy by dx at x1 comma y1 into x minus x1. So this is the equation of normal, and this is the procedure to find the equation of normal. So now let's discuss some questions related to normal from this assignment. Like question number 12. Find the equation of normal to the curve at the given point y equals to x square minus 2x at -1, 3. Y equals to x square minus 2x at -1, 3. So first what we have to do, differentiate both sides with respect to x. Differentiation of y, dy by dx equals to differentiation of x square with respect to x, 2x, minus differentiation of 2x with respect to x is 2 only. So dy by dx equals to 2 is common into x minus 1. So slope of tangent will be m1. Let's describe it by m1 is dy by dx at point of contact -1, 3. So 2 into -1, 2 2s are 4. So slope of tangent is -4. Now we will find the slope of normal. How to find the slope of normal? M2 is, we know that normal is perpendicular to tangent, so it is minus 1 by M1. That is minus 1 upon M1 is minus 4. Minus minus cancelled out. Slope of normal is 1 by 4. Point of contact is minus 1 by 3. So now we can easily find the equation of normal by using the formula y minus y1 equals to m2 into x minus x1. It implies y minus y1 is 3 equals to m2 is 1 by 4 into x minus x1 is minus 1. It implies cross multiplying 4 into y minus 3 equals to x minus minus plus 1. It implies 4y minus 4 3 are 12 equals to x plus 1. It implies x minus 4y plus. This is the method to find the normal. So next question we are going to discuss is question number 13. Find the equation of tangent and normal to the hyperbola. Equation of hyperbola is given 5x square minus 7y square equals to 35. At point of contact is given root 7 comma 0. So we have to find the equation of tangent and normal both. So simpler procedure will be followed, that is differentiating both sides with respect to x. Differentiation of 5x square is 10x square. Differentiation of 7y square is 14y into dy by dx is 10x not 10x square equals to differentiation of 35 is 0. So 10x equals to 14y into dy by dx. It implies dy by dx. It implies dy by dx equals to 10x upon 14y, that is 5x upon 7y. So slope of the tangent is equal to dy by dx at the point of contact, that is when we take x equals to root 7, y equals to 0. So it becomes 5 into x is root 7 upon 7 into 0. So it is 5 root 7 upon 0, that is slope is not defined. And whenever slope is not defined, we know that it means that this tangent whose slope we are going to find is parallel to y-axis. As any line which is parallel to y-axis has its slope not defined. Whenever 0 is at the denominator, we write it as not defined. So tangent is parallel to y-axis, and any line which is parallel to y-axis is given by the equation x minus x1 equals to 0. Equation of tangent is x minus x1 equals to 0. That is x minus, and the x1 is root 7. Point of contact is separated. So equation of tangent is x minus root 7 equals to 0. Now how to find the equation of normal? As slope of tangent is not defined, so slope of normal will be 0 as they are perpendicular to each other. So slope of normal is equal to 0. It is parallel to x-axis, and whenever a line is parallel to x-axis, y minus y1 equals to 0. That is y minus this y1 is 0, point of contact. So y equals to 0. That is x-axis itself is the tangent to this hyperbola, normal to this hyperbola. X-axis is normal, and the line parallel to y-axis, x equals to root 7 is the equation of tangent to this hyperbola. The next doubt is in question number 19. Find the equation of normal to the curve 3x square minus y square equals to 8, which are perpendicular to this normal to this curve is perpendicular to x plus 3y equals to 4. Okay. So if normal is perpendicular to x plus 3y equals to 4, first find the slope of this line, x plus 3y equals to 4. So slope of the line is obtained by comparing it with y equals to mx plus c. So first change it to y equals to mx plus c, minus 1 by 3x plus 4 by 3. So slope of given line, this is the slope of given line. Let's represent it by m1 equals to minus 1 by 3. And let's assume that after this, let's assume that slope of normal, which is not given, is m2. And as this line is perpendicular to the normal, it means the slope of the product of their slope should be minus 1. If two lines are perpendicular to each other, the product of their slope is -1, we all have studied this in previous classes. Now m1 is -1 by 3. m2 is unknown, equals to -1. It implies m2 equals to 3. So the slope of normal is 3. Now we will find one more slope, assuming that the point of contact is x1 comma y1 by the differentiation of this. 3x square minus y square equals to 8. So differentiate with respect to x. Differentiation of 3x square is 6x minus differentiation of 8 is 0. It implies 6x dx. It implies dy by dx equals to 6x upon 2y equals to 3x by y. And so the slope of tangent, whose formula we know that is, what is the formula for the slope of tangent? We all know that it is equal to dy by dx at x1 comma y1, where x1 comma y1 is the point of contact, and slope of tangent we have assumed that it is m2. So in place of slope of tangent we can write m2. And dy by dx at x1 comma y1 is dy by dx is 3x by y. So dy by dx at x1 comma y1 is 3x1 upon y. And one more slope we have calculated as 3. This is also the slope of tangent. So compare them. Slope of tangent is 3. So 3 equals to 3x1 by y1. Cross multiplying y1 equals to x1, and 3 is cancelled out. So this is x1, y1 equals to x1. This is equation number 1. And always we know that x1 comma y1, which is point of contact, lies on curve also, on this hyperbolic curve. 3x square minus y square equals to 8. So 3x1 square minus y1 square equals to 8. And from equation 1, x1 equals to y1. So we can write 3x1 square minus x1 square equals to 8. 2x1 square equals to 8. x1 square equals to 4. And so x1 equals to plus minus 2. So case 1, when x1 equals to 2, y1 is equal to x1. So it is also 2. Point of contact is 2 comma 2. So equation of normal, which we have to find, is y minus y1 equals to slope of normal m2 into x minus x1. That is y minus 2 equals to m2. m2 is 3 into x minus x1 is also 2. Okay, in this question it is parallel to given, and we have discussed it is perpendicular to. So let's change the question for this time. Okay, is that clear to you? I have by mistake taken as perpendicular to. Understood? Is that clear to you?
Yes.
This is actually parallel to, but I'm discussing for perpendicular to. So y minus 2 equals to 3x minus 6, that is, make them to the same side. 3x minus y minus 4 equals to 0 is equation of normal, which is perpendicular to this line, x plus 3y equals to 4. Okay. And second point is also there, when x1 equals to 2 and y1 equals, x1 equals to minus 2, y1 will also be minus 2. So we can find this also. So y1, y minus y1 equals to m into x minus minus 2, that is y plus 2 equals to 3x plus 6. So 3x minus y plus 4 equals to 0 is the second normal, which is perpendicular to this line, x plus 3y equals to 4. Now if you want to find the line, again I'm discussing this original question also. Find the equation of normal to the curve 3x square minus y square equals to 8, normal to the curve which is parallel to the line x plus 3y equals to 4. This time we have to find the equation of normal, which is parallel to the line x plus 3y equals to 4. So find its slope also. In previous case, I have taken that normal is perpendicular, though it was given that it is parallel. So after discussing that case of normal, now let's discuss the case of parallel also. There will be no problem if we assume that slope of this line is m1 and slope of normal is m2. m1 equals to, we have calculated it is minus 1 by 3 slope of line. Okay. And it is equal to the slope of normal also. Why? As they are parallel to each other. If two lines are parallel to each other, their slopes are equal. So slope of normal is minus 1 by 3. And how to find the slope of normal? By differentiating this equation of the curve. So 6x minus 2y into dy by dx equals to 0. That is dy by dx equals to 3x by y. So slope of tangent, we write slope of tangent. What will be the slope of tangent? We all know that slope of tangent is dy by dx at x1 comma y1, where x1 comma y1 is the point of contact. So slope of tangent which we are finding will be dy by dx is 3x by y, so it is 3x1 by y1. So what will be the slope of normal? We all know that slope of normal is minus 1 upon slope of tangent. That is minus 1 upon 3x1 by y1 equals to minus y1 upon 3x1. And one more slope we have calculated, it is minus 1 by 3. 3 cancelled out. Again, it is y1 equals to x1. And on solving, substituting this x1 comma y1 in the original equation, we will get the same point as they were also the point of contact. So there will be no difference. Is that clear to you? X1 equals to 2 and x1 equals to minus 2. When x1 equals to 2, y1 equals to 2. And when x1 equals to minus 2, y1 equals to minus 2. Now, the only difference is that in the slope of the normal, we have calculated this time minus 1 by 3 as it is parallel to this line. So equation will be, if we use 2 comma 2, y minus y1 equals to minus 1 by 3 into x minus 2. So cross multiplying, we get 3y minus 6 equals to minus x plus 8 equals to 0. This is the first equation of normal. And second normal is obtained by y minus 2 equals to y minus minus 2. That is y plus 2 minus 1 by 3 into x plus 2. Cross multiplying, we get 3y plus 6 equals to minus x minus 2. That is x plus 3y, everyone.